Hi everyone, welcome back. So the last video that we did, we took care of the paddle movement. Um, and in this video, we will be taking care of creating the ball. So the ball is pretty much the biggest component of our game. It's the one that is going to be handled by the physics engine completely. So let's go ahead and jump into creating that. The first thing I'm going to do is come up here to Game Object, 3D Object, create a sphere, and just center this out here on the play field. Especially make sure you make the Z 0. First thing I can see here is that the ball is a little too big. Let's get it down here, somewhere about like that. So 0.3, 0.3, and 0.3 will make it. Okay, so if you've ever played a game of Breakout, and I will actually rename this the ball real quick. If you've ever played a game of Breakout, you know that the ball starts attached to the paddle somewhere in the center, and then whenever you give it some input, the ball then kind of breaks off the paddle and goes and hits the bricks. So the way I'm going to do this, at least at first, is by using a concept called childing. So the first thing I'm going to do is I'm just going to take this ball and I'm going to drag it right on top of my paddle, right there in the hierarchy. And go ahead, be a little bit, yeah, there we go, pretty uniform there. So our new position is 3 on the Y. Be careful here. So when I unchild it, my position and my scale and everything changes. And then when I child it back, you can see it all changes. So whenever you're looking at an object over here in your hierarchy and you look over here at the transform's position, rotation, and scale is going to be relative to whatever it is childed to. So right now, my position in the y-axis is 3, because I'm, 3 very miniature units away from the paddle, or the center of the paddle, rather. But if I were to come over here, my position in world space is negative 4.2. So, that said, we're going to go ahead and child this to the paddle, and let's see what that actually does. Since I'm childed to the paddle here, if I were to move my paddle, the ball is going to stay right there with my paddle. Looks good. So, the first thing you want to do, really, with the ball, other than childing it to the paddle, is you want to always make sure if a Unity game object is going to be acted upon by the Unity physics engine, we want to add a component known as the rigid body. So just come up here, component, physics, rigid body. And don't let this confuse you because we did add some elementary physics to the paddle, but it's not being acted upon by the physics system itself. That is just translating our movement. This will actually use the physics engine itself. So with that said, let's unchild this real quick. We'll bring it back. So we have a rigid body. Let's see what that rigid body does to our ball. Okay? It just falls straight down. Looks like the rigid body added some gravity to it. And well, that's really about it. So the first thing we want to do is just kind of uncheck this use gravity. And you would think that we are going to use gravity, but we're not, I don't think. We may not. We'll see later. So we'll just go ahead and, well, no. Let's keep it back up here. The second thing we want to add to our ball is something called a physic material. And if you look right here in our sphere collider, you can see it takes a physic material right here under material. So we will come up here in our project, and we'll right click, go to create in the context menu, And all the way down here, kind of toward the bottom, you'll see physic material. And we will just name the material ball. Now what a physic material does is it pretty much its name. It's going to make a material out of your object. Say you want it to be rubber to be really bouncy, or you want to kind of make it seem like rubber. So that's what we're going to be doing with this ball. So our ball, obviously for it to be bouncy, we don't want any friction at all, dynamic or static. So since we don't want any friction, I guess I'm not going to explain the difference between these two because we won't be using them. But what we do want is bounciness. So let's just do one. Friction, obviously we're going to take the minimum. These two are multipliers. So the friction combined, we're just going to keep that at minimum. And the bounce combined, we'll just keep that at maximum. Now, let's see what this does. Oops. I guess we are, at least for now, going to use some gravity. Let's turn this back on. Well, yeah. Oh. Well, maybe I should add my ball physic material to my sphere collider. So, if you forgot to do that as well. Now let's see. There we go. Awesome. And it's always going to kind of, well, it's getting a little bit higher actually with each bounce. But yeah, the reason for this is because we have zero friction. We're taking the minimum friction combined, and we're taking the maximum bounce combined. So if I was to come up here and, I don't know, just make this 0.8 and the dynamic friction 0.1, let's say, you'll see a kind of a different bounce. Ah, there you go. And that's actually kind of what you would get as like a bouncy ball, you know. But we're not going for a bouncy ball. Oops. We want a truly bouncy ball. One that bounces into infinity, if you will. So, that being said, what we're going to do now, we're going to actually child this back down to the paddle. I think we had our Y at 3. Looks good. And now we will turn our rigid body off. So, with that, we're back to being childed, but we want to shoot our ball out. Let's say, since it's childed to the paddle, we'll go ahead and use this in the paddle script. We'll do this inside of the paddle script. So we'll open our paddle script that we made in the last video. And I guess under our translate, it'll be alright. So let's say we shoot this ball out whenever we press the space bar. Seems pretty good. So we're not going to use the get axis function in this example because I want to show you a couple of the different ways you can use input. We could use the input get axis, and the name for that would be jump, I believe. But for this, I want to show you some other ways. So if input.get key, if you look at this, it takes something called a key code or a string name, but I like to use key code. Keycode.space. So if we've pressed the space bar, and remember this is in update, so this is being called every frame. It's checking to see if we've pressed the space bar. First thing I guess anybody would really want to do is shoot the ball off as soon as you press the space bar. But there's one other check we need to make, and that would be we need to make sure that our ball is actually still childed to us. So or to the paddle rather. If we have already shot the ball, then it doesn't make sense to shoot it again. So what we would do there is if transform this, if this paddle's transform dot find ball, and we're going by the name of the object here, and you can actually see that. So string name of the game object. So if it finds an object childed within my transform called ball, then we're good to go. So the first thing we want to do is we want to make the ball, well, we want to make the parent of the ball be nothing. We don't want to be the parent of the ball anymore once we shoot this thing out. So up here, I think would be a good place. We can actually have a public reference to that. So the way we would do it is this public game object ball. And then all we would do is this ball.transform.parent is equal to null. So null in C# meaning nothing, not a void, there's nothing. So the ball's transform parent is now equal to null. And the next thing we want to do is give it some force. So the way we would do that, we want to move it up. So let's just, we'll create a new vector3 here. And we'll call it force vector. Sounds good. Equals a new vector3. It will be 0. Let's just do something. 500. 0. Yeah, that's going to be pretty cool to watch. And the next thing we need to do is just, we want to get the rigid body of our ball. So we want to get the component rigid body of our ball. In order to do that, we have to use a method in C#, or that's made for us by Unity actually, and that would be ball.getComponent, and this is actually a generic method. It can take an object of pretty much any type that inherits, I believe, from mono behavior. So get component, and we want to get the rigid body here, and then you just close it with your parentheses. Then we want to call the add force method that is actually that is actually a part of the rigid body. So add force is actually a function inside of rigid body. And then we just want to pass it our force vector. Yeah, with all that done, I think we could give it a whirl. So yeah, I'm gonna play it here. There we go, and press space. Oh, null reference exception. So this is a good debugging moment for you guys. Null reference exception means that a reference that we have made to something is actually null. Don't confuse it with this null. This is actually what's null. And if you see it up here, we have not actually put our ball into our reference slot. So let's come here, drag ball over to this bad boy. We will press play again and just press space. And there we go. We're shooting the ball. All right, cool. And as you can see, it can go down into infinity. There he is. So now we can come over here and shoot him, and looking good. Looks all right. One problem that I've noticed, maybe some of you already have, if I'm going right or left, if I'm going any direction with my paddle, and I shoot the ball, it's just going to go straight up. And that's just really not true to physics. I mean, if we were moving in a certain direction and, shot a cannon or something, that cannon would inherit at least some of our inertial speed. So what we would do here is we would come over here on the x of our force vector. And we would just grab our input.get axis horizontal one more time. And we would just multiply that by the same amount we use for our y direction. Let's come over here, save it, play. Let's see what this looks like. So we'll, oh yeah, much better. And we can go off into the right into infinity as well. There he goes, going pretty fast. All right, let's just make sure this works on the left. So it does, good for us. All right, so at that point, I mean, we pretty much have covered at least most of that. So let's go ahead and I guess constrain our ball's movement on the left, right, and top. So what most people would probably guess is that we would use the same mechanics as we did up here for our paddle. But the truth is, we want this ball to be acted upon by the physics engine. So there's actually an easier way to get our ball to bounce off of those invisible walls that we will have on the right and left. So what I'm going to do is I'm going to come in here, create a game object, 3D object, and I just want to create a plane. This is just going to give you a nice little square little guy over here. So in order to really kind of find out what we're going to be doing with this plane, the first thing I want to do is just come over here. Let's make the left wall first. So I will go rotate it -90 degrees in the z-axis. Come over here. By the way, if you have a plane, the back side of a plane is never visible. You can only see the top side of the plane, just so you know. So we want to go ahead and just move this over to the right, and this might be good. We could be wrong. Actually, I think we're going to be wrong. Yeah, so that's actually not good at all. So what we really want to do is just come over here and make sure that this is a position that our ball will actually bounce off of. So just copy this component because I moved it while I was in edit mode. So make sure you copy the values of the component, because as soon as you exit out of play mode, it'll go right back to its original values, and then you can come in here and just paste component values. Let's give this a shot. It looks decent, at least, but it kind of went off camera there. And just keep giving it a shot. That looks pretty good. And we'll just scale it up. That way it looks, that way it'll go across the entire screen height there. And the best way to really get the visual effect of this is, obviously we don't want to see this wall, so we're going to come over to this component right here in our plane, and we will just turn off this mesh renderer. And then let's see what we got here. Oh yeah, looks good. A little bug there. It was a little weird, but we'll figure that out. So let's give this a shot again. Oh yeah, that's a terrible bug. Well, let's see what's going on here. Make sure our ball is 0 on the position. Okay. Alright, so after a couple of seconds of figuring that out, so the thing we really want to do here is down here in our rigid body, it is set to discrete by default. If I play that, it'll probably give me some sort of weird wonky error with the physics, maybe not. It was kind of an intermittent error there. But yeah, oh, there it goes. So it went through our plane. What you really want is the collision detection to be set to continuous. The last thing that I did is just because I realized our angular drag, we want that to be at 0 as well, because we don't really want to be losing any speed as we're going at an angle. And from there, our rigid body should be good to go. Yep, there we go. All right. So what we want to do with this plane now is, well, let's go ahead and turn our mesh renderer back on just so we can see it. We'll just duplicate it. And what we want is for our z-axis, we want this one to be at 90. And instead of it being at 14.8 or negative 14.8, we want this one to be at 14.8. And that should give us the same results, but on the right side. And then I'll just change this left plane, right plane, and should give us the same results for the right side. Looking good. Let's go ahead and grab the top here. I give this mesh renderer. Yeah, so Control D to duplicate. Name this top plane. And, well, yeah, we can use the same. No, we want our z-axis to be negative 180. We'll just, we'll have to turn on the actual visuals to see it here in action and really give it a good position here, but that looks like a good eyeball, I guess. So what we want to do is, we don't need the mesh renderer turned on for this one, but for the top plane, we really want to see. So I just come over here where there's no bricks getting in the way, and you can see it goes off the screen. So let's bring this down till our ball no longer goes off the screen. It doesn't go off the screen, but it's really not where I want it to be. So we're at 6.89. Let's try it at 6.8. Looks pretty pro. Let's try 7.5. Yeah, that's perfect. Alright, so I forgot to do that, so I forgot to copy my value, so we'll just type that in there. And then turn off the mesh renderer. Give the game a play. And there we go. So we've got our top values going on there. Looking good. Got some cool ball physics going on. Oh. All right. Looks pretty good to me. So we have our top plane, left plane, right plane. And that's pretty much it for the ball physics. So let's start breaking some bricks in the next tutorial, and we will start going over losing lives, gaining score, and just overall game over functionality. That'll be the next tutorial, but maybe not the last. Maybe I'll go over some more advanced mechanics and maybe some power-ups, things like that, and maybe getting some colors in there, something like that, just to make it more of a game. I'm not sure yet, but we're definitely going to have the base functionality of Breakout completed in the next tutorial. So see you then.